Hi everyone. So as you go through your homework, I'm going to see if I can troubleshoot some of the homework questions and such so that you can have an easier ride through your homework. Recognizing that most of you have already started the homework, this will be a review for some of you, so just fast forward to, I guess, the section that you're on. This one, hopefully it's not too bad. Find the missing terms of a sequence, determine whether it's arithmetic, geometric, or neither. I'm gonna let you guys figure this one out. I don't think this one's gonna be too bad. So take a look at the next one. Same story. I'll let you guys figure that one out. I don't think it's too bad. Likewise, this guy, same thing. Now this one's a different story. So what's an example of deductive reasoning? So with deductive reasoning, I like to look at it from the broad perspective and then narrow it down to a single instance. Let's see if I can elaborate on this based on the examples they give. A small yoga studio is offering free classes to college students this August. Okay, so that's a single example. So the yoga studio will probably offer free classes to college students every August. That's a general. Okay, so it's going from specific to general. Now, that's an example of inductive reasoning, is when you go from specific to general, so it's not this guy. Let's try the next guy. Example. For the past 2 weeks, a local bookstore has a sale on magazines on Wednesday. So that bookstore should have magazines on sale every Wednesday. See, they give you a specific example and then they go to the general. That's another example of inductive reasoning. The drive to work takes 25 minutes every day. If I leave my house today at 7:30 and have to be to work by 8 a.m., I should make it to work on time. I think that's our guy, because they give a general and then they go to specific. But let's just check the last example to make sure. Taylor plays football. He plays football and in the first game of the season caught 6 out of 15 targets. So he is predicted to catch 24 out of 6 for the next 4 games. See, there you have a specific going to general. So this is our guy right here for deductive reasoning. I think we've got it. This one I don't think is too hard. Just look for the pattern. And this is just another example of arithmetic, geometric, or neither again. Now this guy is a different story. Sorry, I know the screen just showed a different problem and now all of a sudden I got a different problem popping up. I just want to make sure I wasn't going to lead you astray, so I tried one real quick. Alright, here we go. Luis had got a new video game and is using the bar chart given below to keep track of how many points he gets on each level. How many points will he deliver on level N? Alright, there's a couple ways to take a look at this. In my opinion, the easiest thing to do is to just look at one of these. You know what? I'm just going to start with the first one. So for your first bar, it looks like he's at 6, right? So I'm just going to enter the number 6 here in my little scratch pad here. Now, to get from 6, this bar to the next bar, he's going from 6 to 8, right? So that's an increase of 2. So I'm going to write plus 2n. And then right next to that, I'm going to go minus that same difference, so minus 2. So these two numbers, I always have matching up every time. Now I'm going to simplify this algebraic expression. 6 minus 2 is 4, so we're looking at 2n plus 4. I believe that's what they're after. Let's enter that in and see if we're right. 2n plus 4. Look at that. My brain is big. Let's take a look at the next one. So this one's an example of inductive reasoning. This will be a lot like the deductive one, except the exact opposite. So with inductive, you are going from specific and then you go general from that. All right, so I'm going to leave that one to you guys to figure out. This is going to be another example of your cupcake sold chart. So let's see if we can figure this one out now based on this information that we've got here. In fact, you know what? Let's do this. On day 1, it looks like they sold 4 cupcakes, so I'm going to change this guy to a 4. Now, let's see the change here from day 1 to day 2. He's going from 4 to 7, so that's 7 minus 4 is 3. So I'm just going to change this 2 to a 3 in there, and then change this to a minus 2 to a minus 3. So now we're looking at 3n plus 1. So that would be your general formula here, but this problem's a little bit different. They say, well, what happens on day 14? Well, on day 14, we'll plug in a 14 where you see that in there. So we're looking at 3 times 14 plus 1. And if I'm not mistaken, this will be embarrassing if I get it wrong, but 3 times 14, I believe, is 42. Let's see if we're right. Plus 1. 3 times 4 would be the 12, carry the 1, so 3 times 1 is 3, plus 1 is 4. Yeah, we got that right. So then 42 plus 1 is 43. I believe that's our answer, 43. My brain is so big, it is obese. Let's try this one out. Next one, it'll be the same deal as the previous one. I'm going to skip it this time if that's all right. And this, you're just following a pattern. And this one, it's a lot like the other one that we did with the whole n business. I'll skip it this time. This could be interesting. The sum of two composite numbers is always composite. Now, composite defined is not a prime number. A prime number would be numbers that don't have factors other than 1 in itself. So prime numbers would be 2, 3, 5, 7, and so on. A composite number would be the exact opposite. So we need to figure out if we can find the sum of two composite numbers that won't always be composite. So let's try, hang on, let me think for a second. I thought of one. How about this? 4. And there are factors of 4, right? 2 plus 2 is 4, or 2 times 2 is 4, so 4 is a composite number. Try another perfect square, 9. 3 times 3 is 9. That'll make this guy a composite number. Now, when you add them together, you're going to get 13. And 13 is not a composite number. It's a prime number. This should work. Oh, we're cruising now. All right, that ought to take care of section 1.1 for you.